greater than 5? Question mark. 40 is, yes, it's greater than 5. So part of my criteria is good to go. So what's my other criteria? It says, now if I take n and I multiply it by q, what is q in this case? 0.6. So what is 0.6 times 100? Is 60 indeed greater than 5? Sure. So that tells me that I'm all in the clear to take this and move it from a binomial to a normal. Okay, is everybody cool with when we can do this? Yes, so far? There's only one hitch that comes into this, okay? Because we're going from a discrete to a continuous, we have to take into account that there might be a little bit of a kind of an overlap problem to it. So we have to do something called a continuity correction. Okay? Continuity correction, what that does for us is it allows us to have that little bit of a mistake that could potentially happen in this problem. So this particular problem says we want to know when x is less than 43. So I'm going to use 43 as my example. So x is less than 43. What is the closest, using 0.5s, using a half, right? What is the closest thing to 43 without it being 43? And you don't want to go over it. So you want to be as close to it as you can, going a half to the left or the right of it. So we're going to go x is less than 43. So what is one step smaller than 43 by a half? So 42.5. So if this is asking me to go from a discrete to a continuous, instead of x is less than 43, I'm going to test x is less than 42.5. Because I'm not including the 43, I don't care to include the 43. I have to just go before. Now let's look at it in a different light. What if the problem was x is less than or equal to 43? Does that include 43 in it? Yeah. Sure does. So I want to go 0.5 in what direction to still be able to include the 43? Okay. So exactly right. I'm going to go to 43.5. So this guy does not include 43, so I go a step below it. This guy does include 43, so I'm going a step above it. Does that make sense? That's my continuity correction. Let's look at the other way. What if x was bigger than 43? X greater than 43, does that include 43 in it?
No, it should be 43.5.
So I'm going to go bigger than 43.5. Exactly right. Why a little bigger? Because I don't want to include 43, but I want to be bigger than it. All right? And what's the last example? X is greater than or equal to 43. So what am I going to go with that one?
42.5.
Because I want to include 43, right? So I'm going to go x is greater than or equal to 42.5. Is everybody understanding how that continuity correction comes into play? So if I told you I was looking for x is less than 52, how would you rewrite that?
X is less than 51.5.
Correct. Okay, is everybody feeling that? Are we cool, all of us sitting here? If not, this is a great time for you to say, wait a minute, keep talking about it. What if I did this, let's let somebody else answer this one. X is greater than 61. Your mind should say, am I including 61 in the problem? It's like a yes or no, kind of a flow chart. So x is bigger than 61. Is 61 part of that answer? No. So what's the closest thing that's to 61 but not including 61? 61.5. Makes sense? Let's do one more. X is less than or equal to 72. Including 72? Yes. So I want to be the things that are less than it, but I want to include the 72. So which way do I go with it? I go up a little, so it becomes x is less than or equal to what? 72.5. cool? So when do I use a continuity correction? It's I'm doing a binomial, and I'm like, holy cow, these are big numbers. N times P is bigger than 5, N times Q is bigger than 5. All right, so now I'm gonna have to kind of convert my little problem. So how does that come into play? Well, my formula, get out your bright colored sheet of paper, is taking this binomial, and we're like, we want to find the probability that X is less than 43. And then we're like, ooh, big numbers, let's go ahead and check. N times P bigger than 5? Yes. N times Q bigger than 5? Yes. So I'm going to convert it from a binomial, a discrete, to a continuous, a normal. So step 1, let's make sure I have a continuity correction. So in this particular problem, we have a continuity correction, and go ahead and remind me, what is my continuity correction for this? Okay, so now we're looking for the probability. Tell me how to rewrite this. X is less than, very cool, okay. On your bright colored sheet of paper, does it give you the new, like to go from a binomial to a normal? I don't think it does. I don't think it does. So remember, this is N and this is P, right? What is it if I'm going into a normal? Do you have it on there on your bright colored sheet of paper? What is your normal if you look at it? It doesn't show it at all? No? It doesn't say mu here? No? And then it doesn't say variance here, also known as sigma squared. So it's something you have to have in your brain, okay? So our normal is mu, which is the mean, and sigma squared. So let me tell you, how do I get those? So mu is N times P. So if I'm converting from a discrete to a normal, my first step is I'm going to rewrite this. Mu is N times P. So what is, in fact, for this problem, what is my new mu, my new mean? What is N times P in this problem? 100 times 0.4. What was that again? Oh, 40. Okay. And my variance, my sigma squared, is N times P times Q. N times P times Q. So what is my variance in this particular problem? So it's 100 times 0.4 times what? And so what do we get for this variance? What'd you get? Basically 40 times 0.6, really? 24, okay. All right. So step 1 is to do your continuity correction. Step 2, find your mu and find your variance. Is everybody cool with that? So step 1, continuity correction. Step 2, find your mu and your variance. Do you guys remember the formula? Z is equal to, anybody remember that from a couple of weeks ago? Not at all? This could be a long week. I think your test is next Monday. So it's x minus mu over the standard deviation. Does that ring a bell? Kind of, sort of, yeah. Okay, so let's draw this out. What's my mean for this normal that I'm playing with right now? Anybody know the mean on this particular problem? 40, okay? So 40, right? Are we cool there? Now, what are we looking for? We're looking for x is less than what? We did a continuity correction for it. 42.5. Where is that located in comparison to 40? To the right a little bit. So we're looking for 42.5. We're looking for it to be less than 42.5. Everybody following my lead so far? Or if it kind of starting to come back together? So my x is 42.5 minus 40, and then what's the standard deviation? This is the variance. How do I find my standard deviation?
Variance, or is it square root?
Square root, yeah. This guy is squared, that's the variance, and the standard deviation is the square root. So the square root of 24. All right, crunch your numbers for me, get me a decimal.